we have two different types of systems. We have the open loop. Everybody knows what that is. We have the feedback loop, and we kind of also know what that means, right? So open loop essentially is, defined by the fact that you have an output signal that is not dependent on a response that was fed back to the input of your system, right? So basically, there's no feedback in this loop. You just go from input, transfer function, output, right? You have a set point, and nothing is correcting that set point if you deviate from it. Okay? So what are the properties of that? These can also be questions that can come up in your objective, right? Your conceptual questions, right? So of course, as the name indicates, it's not self-regulating, right? Because you don't have any control action that feeds back to the input, right? So therefore, there's no controller that kind of helps you compare your actual to your set point or your desired value because there's no feedback loop, right? So each of your inputs will determine a fixed operating position for the controller. So basically, your input is serving as your controller because as you change this changes, right? So this is your controller because there's no feedback loop. Okay? So when you have changes or disturbances due to external conditions, you are going to get direct output changes, right? So here you can see the changes or external disturbances does not result in a direct output change because there's no way that you can actually influence your system by feeding backwards, right? If you need to make any change, you have to do it manually. So those are kind of obvious properties of the feedback system. And of course, the closed loop is the entire opposite. This is the one that we care about in process control, right? How can we correct errors? By feeding back, right? So basically, it improves on the concept of open loop, but then it has feedbacks. It can have actually more than one feedback to kind of influence your control, your input variable. And you can have summation of your feedback, or you may have comparators that can subtract some signals and all that stuff, right? But what is the main point is that you design those controllers, feedback loops, to maintain the desired output condition that you want by comparing it to the input, right? If you get a desired output, an undesirable output, you compare it to what you wanted, and then you kind of make an action that will correct it. So what does it do, or what properties do we have in a closed loop or feedback control system? You can reduce your errors automatically. You don't have to have an operator there. Once you put your set point, run your reaction, you go home. And you, of course, set your alarms and all that stuff, but it's going to making those transient changes by itself. Okay? Now, if you wait for errors to propagate in the system, they're going to keep growing and growing and growing, right? If you don't have a feedback loop. But when you have a feedback loop, you can improve the stability of your system incrementally before it runs away, right? So once you do that, you can achieve that if you indeed use a closed loop, okay? Also, you can increase or reduce the system sensitivity. If you adjust or maintain the set point range, right? You give yourself an acceptable limit. You can make your system very sensitive or less sensitive, right? If you define a wide range of tolerance, your system is going to become what? Less sensitive. But if you decide a very narrow range of tolerance, that means it's going to keep recommending control actions until it gets the exact range you want. Okay? So when you have external disturbances in the system, you employ something like this, and it's going to enhance your robustness, right? Because even if it has actions that are external, wind, temperature, pressure, or somebody perturbs it, or you have someone that mistakenly stares into a system that they're not supposed to stare in, it's just going to have a reaction to that, right? And it's going to allow you to produce reliable and repeatable performances.